Today, I am going to be talking to you about the concept of momentum, impulse, and how the two are related. Momentum, denoted by a lowercase p, is a vector represented by the equation p, meaning momentum, equals mass times velocity. Therefore, momentum is a quantity of motion of an object measured as a product of its mass and velocity. A collision is defined as a short-duration interaction between two objects. An object moves towards another object, collides for a short period of time, and then recedes. There is momentum before a collision and after a collision, so it is important to find p initial using mass and initial velocity, as well as p final using mass and final velocity. Newton's third law states that for every action there is an equal and opposite reaction. This can be seen using a device known as Newton's cradle. No matter which way the balls are pulled and released, the corresponding balls on the other side will react in an identical and opposite way, as seen in this video. This mechanism can also be used to show how momentum is conserved before and after a collision. In an isolated system, meaning there are no other forces acting on the objects, the total momentum is constant. This is known as the law of conservation of momentum, and it is represented by the formula m1v1 initial plus m2v2 initial equals m1v1 final plus m2v2 final. While the formula I just listed only includes two masses and two velocities, it can be used for any number of objects. Using this formula, we can solve for unknown variables. Let's continue using Newton's cradle to represent what I mean. Newton's cradle has 5 metal balls of equal mass. Suppose the mass of each ball is 0.01 kilograms. If I hold 3 of the 5 balls out of the way and exclude them from the collision, that leaves us with mass 1 of 0.01 kilograms and mass 2 of 0.01 kilograms. If I pull back mass 1 and release it with an initial velocity of 0.06 meters per second, it will collide with mass 2. As we can see, during the first collision between the two masses, the final velocity for mass 1 becomes 0 and mass 2 is set in motion. Using our formula from the law of conservation of momentum, we can calculate the velocity of mass 2. We can insert our known variables into the formula. Because we are trying to find the final velocity for mass 2, we leave it as a variable within the problem. When we multiply the components together for the initial momentum for mass 1, we get 0.0006 kilograms times meters per second, which is the SI unit of momentum. The initial momentum for mass 2 is 0 because the initial velocity is 0 due to the object being at rest. The final momentum for mass 1 equals 0 because this time its velocity is 0 meters per second. The momentum for mass 2 is left with a variable. We can then divide both sides by 0.01 to solve for V2 final. By doing this, we find that the final velocity for mass 2 is 0.06 meters per second. This is equal to the initial velocity for mass 1, thus showing us that momentum was conserved. Now we know how to calculate momentum and understand the law of conservation, but how is momentum related to impulse? Well, impulse is a large force exerted for a small interval of time. It is denoted by a capital J and has multiple formulas that can be used to find it. These formulas include J equals delta P, meaning J equals mv final minus mv initial, and J equals F average times delta T, meaning change in time. When facing a momentum and impulse problem in which the force is not constant, the F average should be used as seen in the formula impulse equals F average times delta T. Another method in which one can find impulse is by finding the area under a force versus time graph, with force on the y-axis and time on the x-axis. By calculating the shaded area, as in this plot, one can find the impulse without using any impulse equations at all. Therefore, impulse equals the area under a force versus time plot, which equals the F average times delta T. And that's it. I hope I was able to give everyone a better understanding of momentum, impulse, the way these two concepts intertwine, and the various types of mathematical problems you'll have to solve involving these concepts. Good luck!